Hello, today we're going to talk about Reactivity 1.3.4, which is all about biofuels. Okay, so biofuels are produced from the fixation of carbon over a short period of time compared to fossil fuels through photosynthesis. So let's talk about photosynthesis. In plants, there are a variety of pigments. Let's talk about just chlorophyll. Chlorophyll is a green pigment that will absorb light, and then it uses that energy to convert carbon dioxide and water vapor, or liquid water, excuse me, into glucose and oxygen gas. So again, plants will take in carbon dioxide and water, and it will produce sugar, glucose, and release oxygen gas. You definitely need to know the reactants and products of this process. So let's go ahead and balance the equation. It's going to take us 6 carbon dioxide molecules and 6 water molecules to produce 1 glucose, and it will release 6 oxygen molecules in the process. So you're fixing the carbon from the atmosphere into glucose. You're taking it and putting it into a place, fixing. And so sugar is a type of biofuel. It can be used by animals as an energy source, or by the plants themselves as an energy source. But and this can come in different forms. You could have like wood, for example. The sugar, the glucose can form up into cellulose, which produces the main structures of wood. And then when humans chop the trees down and burn the wood, you're using that glucose effectively as the energy source. Now, you can also use the glucose to create ethanol. So the C6H12O6 glucose can be fermented to produce ethanol, C2H5OH, and that will also release some carbon dioxide in the process. Ethanol is a convenient biofuel. It can be produced from sugar sources, plant sources, at a reasonable temperature. It doesn't have to get like to crazy high temperatures and pressures, but it can be done very easily through yeast fermentation to produce this ethanol. Now, ethanol is very frequently used as a gasoline or petrol additive, and some people call that gasohol, which is interesting, but that's where you're mixing the petrol with ethanol. A lot of times it'll be about a 10% ethanol solution. But this helps because ethanol is a renewable source. It's less likely to produce some of those harmful byproducts like the nitrogen oxides, sulfur oxides that contribute to acid rain. It's not a petroleum product, which is good. And so there's a lot of advantages to using ethanol. However, certain types of machinery are not calibrated to be able to handle ethanol. So you'll need to find an ethanol-free source of gasoline or petrol. And it can also cause corrosion because it's going to dissolve more easily in water because it can form the hydrogen bonds with water. So if you have a lot of water mixed in, that's going to cause ions to dissolve in the water as well, which can corrode. Pure like hydrocarbon sources are not going to mix well with water because they're nonpolar only. So yeah, ethanol. So we also have like advantages and disadvantages of our biofuels, just like we have with with fossil fuels, but this time is going to be a little bit different. Advantages and disadvantages. The advantage mainly being that it's renewable. You can grow more plants. So it tends to be cheap because of that, but it might take a little bit more processing depending on the situation. They tend to be cleaner. less pollution, less carbon dioxide, nitrogen oxides, sulfur dioxides, fewer greenhouse gases being emitted. But on the flip side of that, you have to then use field space effectively that could be used for growing food. So if you're growing corn that you're using to process into ethanol for gasoline additives, then you're not using that as a food source. And it tends to be more costly to grow the food, harvest the food, process the food, or the biomass of whatever kind it is, to produce ethanol or the biofuel, biodiesel. Then so maybe a higher cost than some of the fossil fuels that we're used to. And then another disadvantage is it tends to have a lower specific energy. We talked about specific energy with fossil fuels. Remember that specific energy is a measure of fuel efficiency by mass. So since it's going to produce less energy, release less energy per unit gram, it's going to be more costly to run. It's going to take more of the stuff to run. So keep that in mind. And I've mostly focused on ethanol, but you can also use methanol as a biofuel as well. So you can make like methane from the breakdown of biomass, and that is effectively natural gas, or you can produce methanol by heating wood in steam, and then you can burn the methanol. I just want to mention that as an option, but usually we're going to be talking about ethanol as like the main source for biofuels here. Okay, so for this example, we have the enthalpy of combustion for ethanol is negative 1,367 kilojoules per mole. Calculate the specific energy of ethanol in kilojoules per gram. So if I've got 1,367 kilojoules per mole, okay, that's with the mole -1. For every 1 mole of ethanol, its molar mass is 46.1 grams. And so I'm going to set it up that way for ethanol. So the moles cancel. And then when you divide, you get 29.67 kilojoules per gram. And so that's your energy, specific energy. Now for this example, they give us octane's specific energy is 47.87 kilojoules per gram. Compare this value with the corresponding value for ethanol, which we calculated in the last question. We got a 29.67 kilojoules per gram. And then it says to explain the difference. So ethanol's is lower than octane's. When it says to compare, make sure that you actually say which one's higher or lower. Point out the similarities or differences when it says compare. So ethanol's specific energy is lower than octane's. And this is because ethanol is already slightly oxidized. So ethanol is C2H5OH. It has some of that oxygen in there. Octane is C8H18, which is completely reduced. When you go to combust it, either of these, you're going to be able to release more energy from the octane because it hasn't been oxidized at all already. Ethanol has already been oxidized somewhat. So when you go to combust it, it's not going to be able to release as much energy.